In this question we are told that S1 of n is the sum of the first n terms of an arithmetic progression A1. S2 of n is the sum of the first n terms of another arithmetic progression A2. We are told that S1 of n divided by S2 of n is equal to 3n minus 1 divided by 7n plus 1. Let us assume that for the first arithmetic progression, the first term is A1 and the common difference is D1. And for the second arithmetic progression, let us assume that the first term is A2 and the common difference is D2. So what is the sum of the first n terms of the arithmetic progression 1? That will be n by 2 into 2A1 plus n minus 1 into D1. And what is the sum of the second arithmetic progression? The sum of the second arithmetic progression for the first n terms is equal to n by 2 into 2A2 plus n minus 1 into D2. We are told that for all the values of n, this ratio is equal to 3n minus 1 by 7n plus 1. We can cancel n by 2 and n by 2 over here. So the simple ratio will be 2a1 minus d1 plus n times d1. We have just segregated the terms which have a coefficient with n and the constant terms. Similarly, in the denominator we will have 2a2 minus d2 plus n d2. This we are told is equal to 3n minus 1 divided by 7n plus 1. And this is true for all the values of n. This would imply that in the numerator, the term which has n and the term which has n in the numerator, similarly the term which has n in the denominator, both of these have to be in proportion. That is d1 divided by d2 has to equal 3:7. Because this is true for all values of n. So as n becomes very large, if n becomes infinity, you know that the ratio will approach 3/7. So that should be the ratio of d1 is to d2. So for simplicity of calculations, let us assume that d1 is equal to 3d and d2 is equal to 70. Now again, if you are looking at the constant term in the numerators and the coefficient of n, again this ratio should be the same. That is 2a1 minus d1 divided by d1 has to equal minus 1 by 3. So if you cross multiply, 6a1 minus 3d1 is equal to minus d1, or the value of a1 is equal to d1 by 3. We assume that d1 is equal to 3d, so the value of a1 will equal d. Similarly, in the denominator, the constant term is 2a2 minus d2 and the coefficient of n is d2. This should be the same as the coefficient and the constant term in the denominator, because this is true for all the values of n. So this would imply that 2a2 minus d2 divided by d2 has to equal 1 by 7. So if you cross multiply, 14a2 minus 7d2 is equal to d2, or 14a2 is equal to 8 into d2. d2 is 70, so this is 8 into 70, or the value of a2 is equal to 40. So if you're looking at the terms, the first arithmetic progression, the first term is d and the common difference is 3d. So the first term will be d, the second term will be 4d, the third term will be 7d, next will be 10d, and so on. For the second arithmetic progression, the first term is 4d and the common difference is 7d. So the first term will be 4d, the second term will be 11d, the third term will be 18d, and so on till infinity. What we are required to calculate is the ratio of the 19th term of a1 and the 19th term of a2. The 19th term of a1 will be a plus 18d. A is d itself, so this is d plus 18 times the common difference, which is 3d, which is equal to 55d. And the 19th term of the second arithmetic progression will be the first term, which is 4d, plus 18 times the common difference, which is 7d. 18 into 7 is 126, plus 4 is 130, so this is equal to 130d. So the required ratio is 55:130. You divide both of them by 5, so this is going to equal 11/26. So the required answer is option C.